Okay, so we know how to take the integral of something. We know how to do it with the indefinite integral, and you've got to do that by hand. We know how to do definite integrals. We can do it by hand or we can do it by the calculator. Some of them you would want to do by the calculator. And I will tell you on the test when you should, when you shouldn't, that sort of thing. I'll definitely do that. But we're going to be doing the area between curves, and most of these have substitution in them. So we did substitution last time, and it seemed to be okay. We didn't have too many problems with that. So there's two methods to do this when you have this. So let's look at the two methods. All right, so here's the original problem. Integral from -1 to 1 of 3x squared times the square root of x cubed plus 1 dx. Okay, so first method, and this is kind of new from what we did last time. We would still do u equals x cubed plus 1, and then du means you take the derivative of that, and we get that. But then you do this. When x is -1, so I'm taking the lower limit. When x is -1, what would u be? Plug in here, and you would get u is 0. When x is 1, which is the upper limit, you plug it in there, what do you get? 2. So now we can rewrite using these limits. So we have from 0 to 2 of u to the 1/2 du. Take the integral of u to the 1/2, so that's 2/3 u to the 3/2. In the original, it was this thing, square root, and remember that's to the 1/2 power. Okay, so we've got that to the 0, from 0 to 2 is what we're evaluating, because we changed those limits. So I've got 2/3 of 2 to the 3/2 minus 0 to the 3/2. And I do that math, and I get 4/3 square root of 2. What's different about that than what we did last week? Well, what did I not have to do here? I didn't substitute back in anything. When I changed the limits, I'm just dealing with u. So that's the difference. You can still, and I tend to do it the other way. I tend not to change the limits. You can still do it this way. And you've got 2/3 u to the 3/2. We'll substitute back in, evaluate from the original limits, you get the same answer. It just depends on what you want to do. I don't care. I mean, it doesn't make any difference to me. I wanted you to see both ways and make sure we understood both ways. So if you don't want to substitute back in, you change the limits of integration. Does that make sense? Okay. All right. I don't think, oh, this. Area between curves. And this is a formula, so to speak. If you have an f of x and a g of x, and you've got an interval from a to b, if you want to find the area between those curves, it's the integral of f of x minus g of x. And you always use the one on top to be the one you're taking from. In other words, if we had curves like that, and we're trying to find the area in here, we'd say this thing was x cubed plus 2x, and this piece right here was x squared minus 5. Then the area in here would be the integral from whatever to whatever of the one on top, x cubed plus 2x, minus, and I would put that in parentheses because you got to make that minus apply to all of it, x squared minus 5 dx. Does that make sense? It's got to be the one on top. And sometimes when you have a curve do this and this, you may have this part where this one's on top, then it switches and the other one's on top, so you may have 3 little integrals that you've got to do the area. We'll have one like that for sure. Okay? All right, we good? Okay, let's do problems. Is that bigger than... on the video. Temperature in here is warm. Noted. Got it. Okay. It is a little warm. Sorry. You can open the door. If it's not noisy, open the door. there's. All right. So here we go. There's two problems here, so we need to work on these. Let me make it a little bit bigger. All right. So here's the integral. We're going to do two things, from 0 to 5 and from -3 to 0 of these two. And it says use substitution. So what would you be? Let's do A first. This guy. Okay, what would you be? And do we need to do substitution? I mean, we can. We need to. Okay, what's du? 1 dy. So we'll just call it dy. All right, so then we rewrite it. Integral from 0 to 5 of what? Okay. All right, so what is the integral of u to the 1/2? Yeah, so you're going to have 2/3 u to the 3/2. Okay, does that make sense? Do we get where we got the 2/3 and all of that? And we're going to evaluate that from 0 to 5. And so if we substitute back in, we've got 2/3 times y plus 4 to the 3/2 evaluated 5 and 0. Okay? So what happens when I plug in 5 here? 5 plus 4 is 9. 9 to the 3/2. You could do it on the calculator, but you could also say, what's the square root of 9? 3 cubed is 27. So you end up with 27 minus, you can't just ignore the 0 this time. 0 plus 4, so you got 4. Square root of 4 is 2. 2 cubed is 8. Thank you. Oh, yeah, I haven't multiplied it by that. I was just getting this part in here. So 27 minus 18 is, minus 8. Thank you. And so 19 times 2/3. And you would leave it like that. Yeah. That makes sense? You always evaluate the upper limit and subtract the evaluation of the lower limit. And then I put the 2/3 at the end instead of at the beginning, right there. But it would make more sense if I did.
I was losing my mind. I forgot that you added the 5 plus 4.
Oh. Gotcha. Okay. Are you okay, Mitchell? Yeah. A little bit crazy. Okay, so do we need to do B? It is the same thing. You won't get the same answer. You're just evaluating it, different numbers. So you could evaluate this. 2/3 of y plus 4 to the 3/2 evaluated, what was it, -3 to 0. So you do that and come up with the answer. And you'll want a fraction, not a decimal. Is it 22/3? I got something else, but I could be wrong. I got 14/3. You were just doing it in your head, right? Just quick. Okay. All right, so we get the idea. On number 2, I want to work the first one this way because it gives you 2, and then I want us to do the second one just totally on the calculator using Math 9. So do this one. So just all that mess. Okay, so here's the first one. From 0 to 5 of r times the square root of 25 minus r squared dr. Okay. So what's u going to be? And then du would be negative 2r dr. Do we have a negative 2 dr? We have r dr, so let's divide the negative 2. So we have negative 1/2 du equals r dr. Okay? And then we're going to rewrite. So we have negative 1/2 times the integral from 0 to 5 of u to the what? 1/2 du. Bless you. Again. All right, so we got negative 1/2 times what outside? 2/3. Evaluated 0 to 5. So we got negative 1/6 times, what was that, 25 minus r squared to the 3. Sorry. Thank you. To the 3/2. 0 and 5. Okay. So let's see what you get. You get a fraction for that one. I got positive. Yep. Anybody concur with us? Okay. All right. What you're going to find is that you can do these definite integrals on your calculator. And so, you know, practice some of them by hand, because you will have to do some by hand on the test. Not necessarily the definite ones, but the indefinite ones. But let's do the second part on the calculator. It's from negative 3 to 3. Do you want me to do it out?
When you plug in the 5,
You have, you see that?
So you're subtracting from 5.
Like that? What done? Oh, okay. What happened to the R? This one? Well, when we let this be U and this was du, well, then we're substituting, and dr is taken care of and this is taken care of. So when we rewrite the problem, we just have u to the 1/2 du, because du takes care of the r dr. Okay? All right. Okay, so now for the second part of that, let's do it in the calculator. And so remember that you're going to do math 9, which gives you this on your calculator, okay? And you have a parentheses. So you want to put the original in, and it would be x times the square root of, I think it just gives you the square root in a parentheses, right? 25 minus x squared, close. So the whole function there is like that. Comma, x, comma, what goes next? We're doing from negative 3, comma 3, close. And let's see what you get. 0. Now, given the option to do it by hand or by calculator, what would you prefer? Okay, yeah. So the majority of the ones that are definite integrals, meaning you have limits of integration, you would do with the calculator. There's
You would put
enough.
that one in first, right?
Do what?
Is that the one you would put in first?
Yes. The only thing on homework, it's going to require fractional answers, so just be sure if you do it and you get a decimal answer that you convert it back to fractions. For me, there's enough indefinite ones that you have to do by hand that if it's a definite one, I don't mind at all you doing it with the calculator. So we're good. Now, let's try this one by hand, and then, I mean, some of you can do it by calculator, some of it, let's try it by hand. Okay. How would you decide what u would be? Well, you could pull the 3 out to start with. So you could have the integral 3 times the integral of tan x secant squared x dx. And then blah, blah, blah. So you could definitely do that. But which of these are we going to let u be? Think about this. If you let u be tan x, what's the derivative of tan? Secant squared? Okay, so you want to think about that as you choose, what am I going to let u be? Because you need the derivative to be the other piece. So if you let u be secant squared, is there a derivative of secant squared? I don't think it goes backwards like that. So you know, have your sheet there and do that. So let's let u be tan x, and so du is secant squared x dx. And so now we're covered. And we can just say, we got the integral from negative pi over 4 to pi over 4 of u du. Do what? Oh, yeah, thank you. Okay, so what's the integral of u? U squared over 2. Okay, so we got 3 times u squared over 2 evaluated at these guys. So, bless you. We got 3 halves. I'm going to go ahead and substitute back in. And I've got, let's see, tan pi over 4. And we can do it like this, squared minus tan of negative pi over 4. Right, because they're definite, because you are doing definite limits of integration. All right, so now it's your job to find out what is the tan of pi over 4. 1. It's 1. So we've got 3 halves times 1 squared minus a negative 1 squared. What's that going to give me? 0. And I think if you printed my notes beforehand, I think the 2 got left off in part of it. It ended up not affecting the answer, but I caught it when I was looking at it later. But the 2 got left off there. But it ends up being 0. Now, try that. That one's not as easy to put in if you were doing that, because secant is not as easy. You have to put in what instead of secant? 1 over cosine. So you could do that one in the calculator, but it really worked out nicely to do it that way. Okay, questions? Okay. All right. Okay, for practice, do one of these by hand, do one by calculator, and we'll just see what we get. this back on. Okay, so this was what we did for u and du, and you ended up with 1/4 du equals t cubed, which made everything work. And then when you rewrote it, you had 1/4 the integral. Here's what you did, 1/4 and 4, so you're going to have 16 on the bottom. And when you plug in, you just get these. There is a lot of room for just little bitty errors. As we saw, we had 3 or 4 people with different answers. Even if you were required to do one by hand that was a definite integral, I would say check it on the calculator. You're going to know then, oh, I made some error, go back and see what it was. Okay? What did you get for the second part? 0? Anybody? Haven't done it? Calculator.
What was it, 3 to -3?
Yeah, it was -3 to 3. Same thing, but -3 to 3 was. Do what? Sure. Any of them that are definite integrals, you could do on the calculator. Mm-hmm. Most of the ones that are definite, having limits, you're just going to be able to do it on the calculator. Yeah. There's enough indefinite ones that I'll know you know how to do the work. The ones that you have plus C, that don't have limits of integration. It's the same stuff you're doing. You just won't be evaluating them in anything. You would get, you would stop where you have u to the 4th over 4 times 1/4. You'd have 1/16, whatever u to the 4th is. I mean, you just write that out. Remember, you don't get to clear it out. You don't get a... Right. Yes. Did you need that? Not you. Uh-huh. We're just going back and forth.
1 plus 2 to the 4th, parentheses, raised to the 4th.
Mm-hmm.
You just cancel it out.
I plugged 1 in, so 1 plus 1 to the 4th.
You just throw me off and you carry the 4 over. It's just
Oh, I just said 1 to the 4th was 1.
That's what I
Yeah.
did.
Yeah, sorry. If that makes it better, I can put a little 4 there. Better? Okay. All right, so we're good on that one? Yeah. It's -3 to 3. Mm-hmm. You got that one?
No, I didn't.
Oh.
It said argument,
Okay, it may be that you don't have the right parentheses or commas or something.
I should do another one.
All right. Okay, this one, a little bit different. So let's look at this one, number 5. We have 1 plus sine 3t times cosine 3t. Okay. You want to try this one on the calculator and see what you get? Before we look at the answer, you would want to be in radian mode, and you go, your lower limit is 0, upper limit is pi over 6, and then it's 1 plus sine, you'll have 3x, parentheses, and then cosine 3x, and then the limits. Let's see what you get. Because this is one that you would definitely want to do on the calculator if you had the option. Somebody let me know if you get, Donnie, you got an answer? What'd you get? 1/2? I got that. Anybody else? You also got 1/2? This? Oh, that was because I did where I wanted to work with you, and I just substituted my limits of integration and stuff. I did this the other way that we talked about, just to mix it up. Right here? Well, it was sine 3t. And so if you're talking, yeah, if it's pi over 6 and 3 times that would be pi over 2. You're not getting? Okay, let's do this. Okay, so all of these are worked out. If you want to check them, if you want to practice, they're all there. But I don't think we need to do them now, right? Are we good? You concur? I think I want to spend what other time we have